Hello there. I tried to take a shot at making a good YouTube video about the basics of mineralogy, and I tried to include various types of information so it'd be useful to give you a very nice look into the basics of mineralogy. Like, this is identifying minerals, knowing how to identify their properties, knowing what the properties even are, knowing how they can differentiate different minerals. And I'm also going to talk about the definition of a mineral and how that definition has changed somewhat. This is all very useful because a very big part of geology and earth science and all of that is going to be mineralogy. So what we have here is a image of quartz. Quartz is a very, very common silicate mineral. Silicate minerals are the most common of all of the rock-forming minerals, so you'll get into that later. What is a mineral? A mineral is a solid, homogeneous substance of natural occurrence with an organized crystal structure. What does this mean? It means the substance is solid in its present form, meaning that liquid water is not a mineral. However, ice is actually a mineral because it's solid. Not only because it's solid, but because of for other reasons. The substance is homogeneous. What does this mean? It means that no matter how I divide it, the chemical composition will remain the same. For example, this will not be present if I take, for example, a piece of conglomerate, which is a type of sedimentary rock. Because if I divide it, I will get different pieces of different rock-forming minerals and sediments that actually form conglomerate. However, if I take quartz and divide it into smaller pieces, the chemical composition will remain the same. The substance is naturally occurring. So this excludes things like steel. Steel is not natural. It's man-made. It is an alloy. So it's not naturally occurring, and therefore it cannot be a mineral. And the substance has an organized crystal structure. So that means it has to have a geometric arranged internal structure that remains constant. Now, note that sometimes you're going to see a mineral that it looks like it's pretty random. It doesn't look like it's following any normal shape. But don't go on saying, oh, that's not a mineral. It doesn't have a geometric structure. But as long as it has an internal structure, it does not need to express that structure externally. Are minerals organic? Well, traditionally, minerals were originally exclusively non-organic. However, the domain of the study of mineralogy has evolved over time to include certain minerals that come out of organic processes, such as certain types of calcite or calcium carbonate, and that is organic. Now, we're actually going to get into the properties of minerals, so like how you identify, what it looks like. So how do you identify minerals? Well, first, I want you to take a minute, pause, and just take a look at these two minerals. What is the difference between them? This may seem like an easy question, like you're going to say, oh, they're obviously not the same. And yes, it'd be correct in saying that they're obviously not the same, but how are they obviously not the same? Well, look, this one it's white. It has a different structure, a different structure than our one here on the right. And you're probably thinking, oh, hey, maybe one is softer than the other, and one is harder than the other. And you'd be correct, because this one is orthoclase. it is a type of feldspar. This one is hornblende, and that is a ferromagnesian silicate. Properties of minerals. Properties of minerals, there are many types, and one of the immediate things you'll be seeing are the immediately visible observation of minerals. What is immediately visible? Well, the color is immediately visible. When you see a mineral, you see the color. That's basically the first thing you see. You're also going to see the shape. What does it look like? Is it long and needle-like? Is it shaped like a diamond or something of that sort? Does it have a regular structure, or does it look more like a mess? And luster is how it reflects when it is exposed to light. For example, some minerals will have a metallic luster, meaning that they reflect a sort of metallic look. For example, hematite is a iron oxide, and sometimes it does not have a metallic luster. However, sometimes it does have a metallic luster, and that's one of the very interesting things of hematite. Properties that can be revealed through simple tests. So now we're getting a little bit more advanced. These are properties that you're not going to see immediately. The first one I want to point out is streak. Streak is essentially the color of the powder that you get when you scratch the mineral against a white plate called a streak plate. For example, if I gave you a picture of hematite when it has a silvery color and a metallic luster, and a picture of hematite when it is red and has a earthy luster, well, then you're going to say, oh, these are two different minerals. However, they're not. If you scratch them on a streak plate, you're going to get the same red-brown streak. Cleavage is how easily minerals will break along flat surfaces. These are flat surfaces, so you're not just breaking it in general. For example, mica is a mineral, and it will break along flat surfaces. A very, very perfect flat surfaces. You can search up a picture if you'd like. Fracture is when minerals break along non-flat surfaces. For example, obsidian. You can search up a picture of that. It sort of looks more conchoidal. It looks like it's not really flat. The fracture isn't really flat. Hardness is the resistance of the mineral to being scratched. What does this mean? This means that this mineral will resist the scratching of something that is less hard than that, but will be scratched by something that is harder than it. This should not be confused with brittleness. Brittleness is a completely different thing. So, the Mohs scale is a scale used to find the relative hardness of objects. So, for example, all hardnesses on the Mohs scale of hardness they're not absolute. They do not stand alone. If you had only one number from the Mohs scale of hardness, you would not know what it means, because they're all relative to each other. For example, it goes from talc to diamond. Talc being the softest, and diamond being hardest. Talc being 1, diamond being 10. And everything between that will be 2 to 9. For example, corundum is number 9. Topaz is number 8. Quartz is number 7. Feldspar is number 6. So, and because it's relative, that means I can have in-betweens. For example, if I have something that can scratch corundum but cannot scratch diamond, that means my hardness of this thing will be about 9.5. Because corundum is 9 and diamond is 10. Specific gravity. Now, before I explain what specific gravity is, it is important to differentiate something. Mass is not the same thing as weight. Weight will be the same anywhere in the universe. Literally anywhere. Mass will be the same. Weight will be different. Now, Weight is the force. The force is something that is applied in a certain direction. It's an attraction or something that is being pushed away. As such, weight will not remain constant. For example, you may have noticed that you apparently weigh less in a pool. That's because the buoyant force offsets some of the force of the gravity, because gravity and weight are related. So it's important to note that mass is not the same as weight, because mass will stay the same, whereas weight will be very different, because you'll weigh less on the moon and you'll weigh more on Jupiter. Now, specific gravity is the ratio between the apparent weight of an object in air and the weight of an equal volume in water. Now, what is volume? Volume is the amount of space that something takes up. Volume does not depend at all at how heavy something is. Volume does not depend at all of how much matter is in the object. Volume does not depend at all on how dense it is. For example, I could have a giant beach ball the size of Earth, and it could have an enormous volume, whereas I can have an extremely, very, very dense particle, extremely dense, denser than the sun, which I will not find that here on Earth, in a tiny particle, and it would have a low volume because it takes up less space. So, the formula is the weight of a sample in air. It just means that you're weighing it in air. And the weight of an equal volume of water. It's the division of these two things. For example, if I have a specific gravity of 3.4, which is a result of the division of these two things, that means that the weight of the sample is 3.4 times as heavy as the weight of the equivalent volume of water. It's important to note that specific gravity and density are closely related, but they're not the same. Do not get them mixed up. Special properties. There are lots of special properties, but I'm only going to talk about two, and possibly one more. Radioactivity can be an indicator of certain minerals, such as uranite. This can be detected with a Geiger counter because uranite emits subatomic particles. Double refraction causes a ray of light to split into two. This means that if I have an image and I hold it behind a sample of something with double refraction, that means I'll get like two copies of that image. Something else to note is the reaction of hydrochloric acid. Hydrochloric acid will identify lots of rocks. Not rocks, minerals. For example, calcite. Calcite can be very easily identified by a strong effervescence in hydrochloric acid. So can rocks such as dolomite or siderite or stuff like that. Mainly carbonates, like azurite or malachite. Well, that concludes my video. Thank you for watching.